to all of you, all the participants, and Professor Biplab Sikdar from NUS. So this course is a 7 days course. 6 days we have the lectures and 7th day is the exam. So we also conduct the exam in the last day. So I just introduce a little bit about IIT-BHU. So this course is conducted with the help of Computer Science and Engineering Department. So in the Computer Science Engineering Department, we have around 400 students and 17 faculty members. And this department comes in picture in 1984. This is a little bit introduced about the department. About this course, so we got around 298 applications. Out of 298 applications, we shortlisted 62 applications. And 62 applications, around 1/3 applications is faculty members, 1/3 is undergraduate, and the higher student, 1/3 is the research scholars. So we classify into 3 categories. Based on this, around 16, 18 faculty members, 18, 20 undergraduate, 18, 20 research scholars, students. Finally, we have 62, so today I think registration is 52, 54. So very possible we can find out up to 60. So today lecture is 1 p.m. to
4 roughly.
Yeah, roughly 4 p.m. And tomorrow onwards, we will discuss most probably in the morning session.
9? You want to discuss later?
We will discuss, and we will inform you. After class, we will announce. Lunch menu is there, 11:30 to 12.
So most probably by 8:30 or 9, kind of.
Okay.
So once again, thank you all the participants and welcome.
Thank you very much. Thank you. So my name is Biplab. So I'm coming from the National University of Singapore. So I guess I'll talk to you for the next 6 days about IoT and machine learning. So the way we will do is hopefully we'll have 3-hour lectures every day, sort of, roughly. Some days maybe 2 hours 50, some days 3 hours, and roughly 3 hours. And what we'll do is somewhere in the middle, maybe around 1.5 hours roughly, or 1 hour 20, let's say, we'll have a 10-minute or 15-minute break. I can't speak for 3 hours. You don't want to hear me speak for 3 hours. So we'll have a break in between, okay? And the way we want to do it is very informal. If you have any questions, just stop me, okay? You don't have to wait till the end of the lecture or anything. You have a question, don't feel shy, raise your hand, and we'll just stop, okay? So it goes that way. So this is sort of a brief overview of what you want to do in this lecture, or in this course. So we have 6 days, and this is sort of the outline. What I didn't know is, what's your background, right? And I think there's a whole spectrum of people here, starting from what I feel is undergraduates, all the way to PhD students and sometimes faculty and so on, right? So I would think that you have a very varied background, and I don't know how much of various things you know. So maybe we'll change a little bit as we go along, and I have a better idea about what your background is about, right? So anyway, today we'll start with introduction to IoT, applications, protocols, and so on. And tomorrow we'll get into security. And then from that we'll see where we go. Okay? All right, so let's talk about IoT and what IoT is. So just to give you some history, right? So this guy up here is Leonard Kleinrock. Right? So he is a professor at the University of California in Los Angeles. Right? And what he is standing by, this was one of the first nodes in the internet. Right? So this is how things used to be back then. This is one router or one computer. And the first internet sort of came out back in 1969, and we had just 4 nodes. Right? There was one in UCLA, Los Angeles, and the other 3 were in. So this is Santa Barbara, again California, SRI, this is in San Francisco, which is again in California, and the 4th one was in Utah. Not in California, but fairly close by. And the first packet was sent, let's say October 29 in 1969, so that's how much? Almost 50 years, right? Yeah, 48 years roughly. And what we used to do in those cases, now at least the younger ones among you, you're familiar to having these things, right? These phones and so on. So you have your own personal computer. Even when I was a student, so I've come back to UP after almost 20 years. I used to be an MTech student in Kanpur. Right? And in those days in Kanpur, what we had is the computer center had the computers. Right? We didn't have PCs, we hadn't seen laptops or anything. Right? So we had to go to the computer center, and there were monitors there. We would call them dumb terminals. We would sit on those monitors, log on to a central computer, and then get whatever we need to do, right? So back in the day, that's what things were. So you had to log on to a central computer in order to access resources. Nobody had their personal computer. So the first thing you would do is you would say login. You would give your ID, right? You would say LOGIN. You would give your ID, then you would give your password, and you log in. So these guys typed in LOG, and then G went, and the system crashed. It's okay. We sent the first packet on the internet, right? So that's how this thing started. And this thing sort of shows you how the number of nodes in the network sort of increased. Goes a bit fast, so we're now in 66, 67. It'll loop through, and I'll talk about it back then again. So let's 83, 84, 86, 87, still going. All right, so starting from 4, then we started adding nodes, more and more nodes. Now you see it going outside to Europe and so on. And in the 80s, you'll see there are not nodes anymore, but we have networks. And there's so many nodes that we can't represent them anymore. So things started exploding at some point. But in those days, most of the users of the internet or the network were academics, research organizations, military, and so on. The general public didn't use the internet. And the most common application was Telnet. That was a login, that was the application. So we used to use it back 20 years ago in order to remotely log into a computer. That was the most common. And then email started in 1971. And if you look in 1973, 2 years later, roughly 3/4 of all traffic in the network was email. Nowadays it's very different, but back in the day it was like that. Other common protocols back then, file transfer protocol. That's for uploading or downloading files. And if you have a phone which is on 4G, right? Everything is IP based, right? Everything is on an IP network. So, but this is not a new concept. The first voice protocol was 1977, really old. But back in the day, things weren't so good because the bandwidths were limited and everything like that. And then the other things were mailing lists where people could discuss various topics and so on. Right. So now what happened is, so till maybe late 80s, early 90s, the internet was really the domain of academic researchers and some military organizations and so on. So what really changed was the invention of something called the HTTP, or Hypertext Transfer Protocol. And what this allowed us to do is access information much more easily. Find information, download information, view the information much more easily. And that sort of changed the way we use the network. And that's when we started coining the term the internet, right? And what it led to was normal people, not my parents, but maybe your parents and other parents, they use the internet now to buy things, to make WhatsApp calls and whatever, right? And the few things that changed initially, this is late 90s, early 2000s, internet commerce. You could buy things on the web, right? Amazon came up, and that was one of the original ones. And late 2000s and so on, we had social media, Facebook, what else? I think in India in those days there was something called Orkut. Some of you were on that at the time. Doesn't work anymore. And now we have LinkedIn is professional and other things. And what is gearing up now is what is called the sharing economy. Right? Airbnb, if you've heard of it. So if you have a home, you have a room in your home, which is lying idle, and let's say you're lucky, you live in a place like Varanasi, which is very touristy, you want to rent out your room, you go to Airbnb, right? So that's sharing economy. If you go to China and Singapore, for example, where I am, anywhere you walk along the road, you'll see bicycles, yellow colored, orange colored bicycles. So they're all sharing bicycles. So you want a cycle, you go up to the bicycle, you scan a QR code on the thing, and the lock opens. And then when you're done with the cycle, you just park it, scan the code again, the thing locks, and you're charged like the equivalent of, I don't know how much it would be, maybe 5-10 rupees per half an hour or something like that. Right? So fairly cheap. So that's what is the current state of the internet now. So where are we? And I showed you this the graphic which said we had started with 4 nodes, 100 nodes, and so on. And this is one way of visualizing the network that is now. Right? By the way, but if you're doing research in computer networks and you're looking for network-related data, a very good source is this GIAN. This is maintained by the University of California in San Diego, and they do all kinds of measurements, topology, link bandwidths, and things like that. If you need to use that in your research, go to GIAN. And all of this is, since it's funded by taxpayer money, this is all free. You can download it, right? So this is one view of the internet. I think this was 2015. I can't read anymore. It is, but yeah. But the thing is, we are not even trying to represent nodes here anymore. It's just billions of nodes. You can't see them. So these are sort of subnets, right? And so on. And still, the structure is so complex that it's very hard to visualize. So what I'm trying to get to here is networks are dense, a lot of users on the network. So we were talking about all these kind of killer applications, right? So what is the next one that is coming? And many people believe that it's the Internet of Things, right? And then you have seen probably such things which say, how much money would the market be worth for IoT? Different people, have different projections. How many devices would be, depending upon whom you believe, it's in the order of few tens of billions. Cisco says 50 billion, IDC says 32. Doesn't matter, but roughly in the order of tens of billions of devices, right? And this sort of shows you how much the data will grow from 2013 to 2020, right? So within a span of 7 years, traffic is going to increase tens of times and so on. Right? So that's it. So what is this Internet of Things? If you look at, there are various definitions. But what it really is instead of reading through all these words, what it really is, instead of humans communicating, right? If you look at historically what has happened when the network started, we had remote login, right? So who was logging in? A human. I sat in front of the computer and I typed login. Email, I sent the email. Right? Even internet, when I would browse the web, it's a human popping up a browser and then putting in an URL and then getting access to the data, right? So far, one end might have been a computer, but the other end definitely was a human. In some cases, probably both ends were humans. Right? What is changing in the IoT is that the messages that are being exchanged in the network are not by humans anymore. They are being originated by machines or things, and they are being consumed by things. So a human doesn't control when a message will be generated. A device or a node or a thing will decide on its own when to do it. Right? So that's sort of the Internet of Things in a nutshell. Right? So let's look at some use cases. Right? So this is one. So this is Australia. So if you go to the northeast coast of Australia, they have the Great Barrier Reef. Right? It's very pretty if you're into scuba diving and so on. But what happens is because of climate change, ships going by and spilling oil and so on, the coral reefs down there, they are being destroyed. Right? And as a government or if you're into conservation, you would want to know what's the impact of various things on these, what's the impact of climate change, what's the impact of movement of ships on the surface, but what's the impact on the coral that is growing under the water. So there are these buoys, and they have sensors, and you see a solar panel and so on. And what they do is they collect all kinds of information and send it out. Right? So this would be one example of a very, very specific application of IoT. Right? So there are these devices which are on their own. They collect data, they send the data somewhere, and hopefully it's being analyzed and then you figure out what to do. Another example. So here in India, when we go to what do we call it, pharmacist, you get medicines which are in a metal foil of some kind, right? Most of the time it's like that. But this is how you would get medicines in the US. You would go to the pharmacy, they would give it to you in a bottle like this, right? And if you're old, like for example my own mother, she doesn't remember too many things anymore, right? So you tell her you have to have this 5 medicines, 2 after lunch and 3 after dinner. She won't remember anything, right? So what this thing on top here is a sort of a sensor, and it measures whether a pill was taken out or not. And you can program the prescription into it. So it knows that one pill should have been taken out in the morning and let's say one after dinner. If you don't take it out, then it'll send a signal to, to either the doctor or to the patient's caring person, maybe son or husband or whatever it is, right? And then they can go and tell that it's time for you to take your medicine. So that's another very specific case example. Agriculture. So, we had the green revolution in India maybe 30, 40 years ago. And one of the things, there were two driving factors, I think. One was irrigation. People had water to give to their crops. The other was the use of pesticides. Right? Now you could control the infestation of insects and other things and so on. But there's a downside to it. There's no downside to the first part. Maybe there is, I don't know, but at least there's a downside to the second part, the use of pesticides. Let's say you spray pesticides on your crop, and next day you water it or it rains. What happens? The pesticide dissolves in water and it goes underground. Right? And when it goes underground, slowly it seeps into the water table inside. So next time you have a tube well or something in that region, you will be pumping out pesticides. So you don't want that. Right? So what you want is, but you don't want your crops to go die either, right? So you want to use pesticides, but in the most optimal way. So what people have done is they have sensors on crops that look at various things like, for example, they can take pictures of the leaves, send it, and an automatic program will analyze those pictures and see, are the crops being infected or not? If they're not infected, no need to spray, right? There are also cameras which track the movement of these insects as they fly out. And if you discover that something is going on, then you can spray it with whatever, right? So you can do much more precise application of insecticides in this case. So these are very, very specific things, right? You could even look at much more general or large-scale systems. So for example, a very common example is retail. Right? Let's say you run a shop or a supermarket chain. Let's say you have a shop and one of the things you sell is milk. Right? How much milk should you buy every day? Ideally, you should buy just exactly as much as you sell. If you buy any extra, what you have to do, you have to store it. In retail, storage is the biggest concern of most people. If you have storage, if you have to store something, that means you're not selling it. But you have to spend some time, you have to spend some space and other things in order to maintain it. If it is milk, you have to put it in a refrigerator, otherwise it will go bad, right? So no retailer wants to have excess inventory. It's not just retailers, even factories, right? If you think of a car factory, you have to put in many, many things together, right? The engine and the wheels and the steering and everything. All those things are being manufactured in different small factories and they're being assembled at some place. Ideally, you want to control all of these productions such that it's not that you produce more wheels than you need, right? You don't want to produce more engines than you need. So the technical term for that is just-in-time production, right? You want to know exactly today I will need 5 engines. So you make 5 engines that day. So you don't have to store those engines. Storage costs time and money and space. Right? So in order to do that, what most retailers are interested in is how much are people consuming? What do people consume? There are seasonal items, right? Sometimes in the winter we buy certain things, or if there's Diwali or whatever festival, right? Certain consumption of certain items goes up. So you want to know what's going on. You want to know how many things you spoil. And this impacts not just the store. Imagine things going back now. It's not about how much storage space. And again, if you have a big shopping, I don't know what's it, but in Calcutta, at least where my family is from, we have something called Spencer's. Right? That's a shop, like a supermarket chain. Not big by, let's say, Western standard, but fairly big still, right? And I'm sure there are others. Right? So for them, for example, they need to know, how much display should I give to a particular item? Right? Should I spend 2 shelves for Coke, Pepsi kind of things, or 1 shelf? Right? So those things, we may not pay much attention, but if you're a business owner, these are very, very important things. So what I'm trying to get to is that the data that you gather, right? If you could measure exactly how many Pepsi bottles or Coke bottles people are buying, then you could order accordingly. And you could have that on shelf. So it's not just the impact on the shop itself, it goes all the way back to the distribution chain. It impacts, for example, how many trucks you will hire to get your stuff in. Right? It impacts how many bottles of Pepsi or Coke. I don't care about Pepsi or Coke, right? So don't take me that, oh, he prefers Pepsi or Coke. But I'll tell you, I prefer Thumbs Up. But after Coke took it over, they ruined it. Anyways, so as a kid, when I used to drink Thumbs Up back in the 80s, in Hindi there's this word called jhag. You understand jhag? It was much more. Now it's like sugar syrup. But anyway, that's off the window to our discussion here. So where was I? Yeah, so it involves various things, right? So if you have the data, if you could collect what people are doing, then you know then you can impact your whole chain of things, just from the shops all the way back to the producers. So there is a potential for impacting all the way through. And just to take one last example where I'll sort of go into a little bit more detail to see how things impact, I'll take an example of a smart city. Right? I think India is in a process of making, I don't know, maybe 200 smart cities, 250? Somewhere in that range, right? So something like that, right? And there are many aspects to being a smart city. And one of them, which I picked up, was waste management, which means we all generate waste, right? And then we either put it in a bin outside, or we throw it through a chute somewhere, and then people come in and collect our garbage, right? And in many of those places, this is done through a truck, like maybe not here, but where I live, or when I used to live in so there'd be a truck like this, which would come and fill up the bin, and then take the garbage and go. So if you look at a system like this, there are many stakeholders. There's the consumer like you and I, we are the ones, we don't want trash outside our home, right? We want it to go as soon as we generate it. So there are the citizens who are involved. Then there's the government, which is supposedly responsible for doing this. And in many cases, the government will not do it themselves. Maybe here we do it, but in many Western countries, the government doesn't do it, they will outsource it. They will hire a private company, right? Probably, I don't know how you do the security here, for example, in BHU. Probably IIT-BHU doesn't have its own security guards, they hire a security firm to do it. Maybe not, but you understand what I'm trying to say, right? So the government may give the contract to a third-party company saying you are responsible for taking all the garbage. That third party in turn may hire trucking companies which will come and pick up the garbage. There are many layers to these usually, right? So what these guys have is, so they have these trucks, and there are many things here. So for example, they have a camera inside the dashboard or somewhere here where the driver sits, and the central look facility can see what the driver is doing, like sleeping or talking on the phone while driving, whatever you want to look at, you can do those things. There is a GPS receiver on these trucks, so you know exactly where your truck is at any given point in time. Right? There are sensors, for example, on the tire. So they know whether your tire is inflated or deflated. Why would I care? Because if the tire pressure is not high enough, you will consume more fuel to go, right? There are weight sensors which see how much trash you have in there. So you can get all of this data. So how does it help us? It helps, for example, city administrators, your government, the fleet managers who say, okay, which direction my truck should go, which is the best route for them to take. So just as an example, if you can get the data that says, on this road, the truck fills up within 1 kilometer. Right? So what does it tell you? As compared to another road where the truck fills up after it has gone 2 kilometers. That means in the first road, you need to put more trucks, right? So that helps you to do planning and so on. Also, for example, there are so many sensors in the truck itself, so that sends data. Why does it help? What mechanical engineers call preventive maintenance. So you know that something is going to go wrong in the truck before it actually breaks down. Right? So you can take it to the service shop and get it fixed and then whatever. And this is sort of a, for a technology people like we are, this sort of shows us what happens. So there are these trucks which get GPS signals, and then they may send it through cellular or Wi-Fi or whatever it is. They will send the signals, and then it will ultimately come to a central server or a database. And then you will analyze this database to figure out what you need to do. That's the system kind of specification. And we sort of talked about what these things do. So hopefully, the idea here for me was to give you an idea about what IoT applications may be and how they can help us. And the bottom line is, they have a wide range of applications. Right? It's not just service industry, it's not just technology. For example, energy. So if you're in the power business, we talk about smart grids these days. Right? How do we handle smart grids? Development of green technologies, healthcare. So we have sensors on our body now. Another example might be, let's say you are diabetic. Right? A lot of people in India have diabetes. And if it goes very severe, you need to inject yourself with insulin. So now there are these automated insulin pumps. You just put it here. It measures your blood sugar, and if needed, it will just automatically pump it. So that's the healthcare application. There are a lot of things to deal with safety, security, and so on. Safety application. So now anytime something happens, you hear there should have been a CCTV. Right? So what's a CCTV? It's something like an IoT, right? It's a thing which measures, which captures video of what's going on, and then it sends it out. Right? And then business and economy that we talked about. And if again, we sort of talked about this, but if you look at how the evolution of IoT was, so this is the pre-internet era, back in the 80s and so on, 70s and 80s. All the data in those days was human to human. I would send an email, right? I would send an SMS or whatever it is in those days, and then we had the internet of content. So this is where HTTP became popular. And in this case, most of the things people were doing were basically getting information, reading news online or whatever it was. Right? And early 2000s, we had the internet of services, and the most common would have been e-commerce in those days. People slowly started getting on to buying things online. And about 10 years ago, it was the internet of people in some sense, and that was when social media took off. Facebook and then whatever. And the next one is the Internet of Things, where everything will be sort of driven by machine-to-machine communications, two devices talking to each other. And there are all kinds of applications for it. So, any questions so far? All right. So if you look at, now let's look at it from a technology. When did I start, by the way? 1 something? 110? 110, so 137. Right, so we're okay. Right, so this is sort of the evolution of IoT, right? And this is a look at the things that we could probably connect. So I think these are biomedical things, your phones, devices on cars, sensors, and so on. So if you have been in this business for a while, right, if you've been looking at computers, networks, and so on for the last 10 years or 15 years, one thing you would say, okay, so IoT sounds very much like sensor networks, right? What we have is we have devices that are collecting data, and somehow we are using that data for something. So is it a sensor network? And the honest answer is, to some extent it is, but there are other things, right? So the whole thing started with the, as technology progresses, things become cheaper, right? So my phone here is much more powerful than the super high-end supercomputer from 1970s. Right? My phone is more powerful than the Cray 3 supercomputer, which let's say came out in 1977. And it's so much cheaper. Right? So as technology progressed, we could miniaturize things. Cost of making things became cheaper. And so we had all these sensors. So that was late 90s, early 2000s, so we could miniaturize and then make sensors and so on. And then we had all these kinds of sensor networks, and then nodes would collect data. We would send them over the network to some server or to the end user and so on. Right? So now, what is different? Right? So one thing is the scale. Sensor networks, we did envision them to have a lot of things, but the kind of applications were sort of limited to things like environment, some military applications and so on. It's much more larger scale now, and now we also think it will be everywhere. It's not just battlefield or crops that you're monitoring. Even this room may have 20 different sensors, and you walk outside with the sensors or whatever there. Right? And everything will be interconnected. When we used to talk about sensor networks in the past, they were all isolators. Okay, so this sensor network monitors crops, and that's all it does. Right? This sensor network monitors temperature in this room, and that's it. Now, there's an integration. And that's another thing, sort of unrelated to our discussion here. That's when, when a single company sort of takes over everything. And that's what people worry about. If somebody like Google knows what you buy, what your email is, then they have information about everything. Right? There's nothing that escapes them. Right? So that kind of integration could be good, could be bad. So we need to be worried about this. And one of the bigger things that has changed is this big data and cloud computing and machine learning. Right? So in the 20 years ago, all we cared about is gathering the data. What do we do with it? Didn't pay much attention to it. Again, in the last 20 years, things have changed both in hardware as well as software and learning techniques, so that we have come to a place that all this data can be more meaningful now. We can exploit that data to do something really useful. And that really is the biggest change. It's not just that we can collect data. We could collect data earlier. Now we can collect more data, that's fine. But how we can use the data. That has been the biggest change. This is the change. And we can say different names to the same thing. Artificial intelligence, which was the main term which we used back in the 70s and 60s. We also hear it now. Then machine learning, and these days the other word which you hear a lot is deep learning, which is sort of a special case of one particular aspect of machine learning called neural networks. Right? So deep learning comes from that. But the fact is that because of advances in these areas in the last 20 years or so, things have changed to a certain extent that it now makes sense to integrate all of these data together and then get something useful out of it. So now let's go, and today what we will do, so hopefully this was sort of an introduction to IoT in very, very general terms, and what we will do now is we'll look at it from more of a technical perspective. What does it require to get an Internet of Things to work? What are the technological components to it? And that's sort of the plan for the rest of the day. So if you look at the architecture of the framework, it's fairly simple. At the bottom you have things, right? Whatever is generating data or consuming the data. By the way, so far I have only been talking about generating data. All things in the IoT don't have to generate data. So in terms of sensors and so on, so we have sensors and actuators. Right? What are actuators? They can operate on signals that you send to do certain things. So for example, a switch could be an actuator. If there's nobody in this room, you send a signal through your phone, it turns on the light. Right? That's a simple actuator. More complicated actuators could be in a power grid. There's going to be let's say a wire has tripped. So what do you need to do? You need to disconnect the relay. So how do I do it? I send a signal to the relay and it trips. So you disconnect your different parts of the network and you don't damage things. Right? So those are actuators. So these things could be both sensors as well as actuators, but they're at one level. They usually connect to the network through a gateway, and then they use a communication network, usually the internet, could be your own private network too, for all that matters. Usually it's the internet, and then it goes to the application. And this application usually we think of in terms of the cloud or something else. Most of the data is stored somewhere else. They're definitely not stored on the sensor itself. Right? And you could either look at it from one single application, but the most common one is horizontal, where you have different kinds of things. They're not all temperature sensors, they're not all humidity sensors and things like that. A wide range of devices. Maybe medical devices and weather sensors. All kinds of things. They get their data and hopefully they send it to a common infrastructure. And if you are one of the application developers, you can go to this common infrastructure and get whatever data you want. You're not limited to just one kind of data. And then you run your application on it. So this is a very simple architecture. There's nothing very complicated in there. So in terms of, again, potential impact, I guess we talked about this. So then we have medical devices, industrial devices, vehicle, transportation systems, retail systems, and so on. And this is some of the other potential impact of where, maybe these slides should have it in front, I guess. But, this shows you how many devices will be there in the network in 2020. So if you look at about 15 years ago, there were 6.3 billion people in the world. And how many network connected devices were there? 500 million, pretty small. Back in about 2007, there were more devices that were connected to the network than people in the world. How does that happen? For example, I have a laptop and I have a phone. I have two devices connected. So it's possible. And there are more devices than humans. And it will grow really a lot in the next 5 years. And then the data that is being generated. So the total volume of data will increase for sure, right? But what's also of interest is to see who is generating the data. Right? If you look at 2011, most of the data is from smartphones and laptops and notebooks. Right? And it has grown to the fact that now smartphones generate more data than laptops and notebooks. And you know what this data mainly is? It's your Facebook or social media. People take 20 pictures and 5 videos every day and upload. Right? That's where this is coming from. And what you will see is that this machine to machine is this purple one, which was pretty tiny, and it's going to grow in volume. But another thing when you're doing technology is it's not just about technology. A big thing is money. If there's no money in it, nobody will deploy it. So if you think about human users, right, of a cellular network, in India you're very lucky. It's very, very cheap. It may not feel like that for many people, but it really is very cheap. Okay? So I am here on a plan for 1 GB per day, right? And I think I paid 300-400 rupees. And in Singapore, my plan has 3 GB per month. Right? That's all I get, 3 GB per month. And I pay about 2,500 rupees for that. It's orders of magnitude difference, right? So, but anyway, so the point I'm trying to make here is, these are being generated by humans and so on, right? But if I am Vodafone or whoever, Jio and Reliance Telecom or whoever it is, what do I care about? I care about, okay, I have to carry all of these traffic. How much money will I get out of it? If it costs too much and I get too little revenue, I can't sustain my network, right? It's not going to work. On the other hand, these machine-to-machine communications, in many cases, these are owned by industry. If I'm a power grid operator, I deploy these things in my power grid. We took the example of the waste management thing, right? Those trucks that gather garbage or rubbish at the end of the day. Who owns it? Some company. So whenever there's a company involved, they're willing to pay money. Right? Usually that's the way it goes. Corporate clients are more valuable than normal clients. If you take an airline, take any airline, you and I, we will go in the normal economy class, the cheapest tickets, right? If you're in a company and you're in the management, you'll fly business class. Right? So corporate clients are always more valuable to an organization than you and I. And this particular bit, this purple bit, is the IoT traffic, pretty small. And the revenue generated here will be more than this because it's corporate data. They are willing to pay more for services. So even though you may say, oh, this is only 1/10 of all of this, doesn't matter. Its value is much, much more. Right? So if I am a network operator, I worry more about this than this maybe in some ways. Anyway. So these are some of the money people think they will make out of those things.
Sir, why smartphones are not in machine-to-machine communication category?
So I guess in this case they're not in the machine-to-machine category because in this particular case the data that is being generated by the smartphone, a human has generated it. I took a picture which I'm uploading on Facebook. So it's not that the phone itself took the data and it's sending on its own. A human is involved. So it's not, that's the reason why you don't. And so let's look at the things then. Now let's come to, so I guess I jumped the gun before. I said we are looking at technology. Now we are really looking at technology, right? So what are these things that we talk about? So at the very, you could classify them again, right? At the bottom end means, not very fancy. At the bottom end, you have these resource-constrained devices, basically sensors, which don't have sufficient, well, they have some, but they're not really rich in terms of how much energy they have, how much memory they have, what is the CPU speeds and so on. Right? So these are the low end. And they have some very, very basic functionality. As an example, environmental monitoring. So what they're doing is they may take a temperature reading every half an hour and send it out. It's fairly simple. At the middle end, you may have a little bit more capability. So for example, home monitoring. If you have let's say, a surveillance camera or something else in your home, the good thing about being in a home is you can always connect to the wall sockets, right? So you don't really have to worry about power so much. If you're deploying these outside, you have to worry about power, right? And then industrial automation. So there you don't have to worry about many things. You can spend more money. And then at the top end, we have things like medical applications. If anything to do with the human life, you don't want to take any chances. So any technology you develop or any sensors or actuators has to be really, really reliable. So all medical applications, and of course military applications. Military doesn't joke around, right? So you have to have the top end hardware here. And the other technical issues. Let's talk about this. So now we are talking about 50 billion users, 50 billion internet devices in around 3 years. If there is a device on a network and it wants to send data or receive data, what does it need? It needs an address, an IP address probably. It's much easier. So if you talk to a network administrator in your university or in your lab, they will say, okay, I have 500 users, 5,000 users, manageable. 5 billion, very, very difficult. So those things. Naming, addressing. Scalability of network architecture. So we all have Wi-Fi here, right? And maybe in your home you have Wi-Fi. In your hostel or in your office you have Wi-Fi. But you have probably often experienced that if there are too many users who are active at the same time, you don't get much data. Right? Your throughput decreases. Why? We can talk about it, but it's because the way people, they do channel access. We have something called collisions and so on, and so things happen. Now, if a Wi-Fi access point cannot handle 10 users, how is it going to handle 5,000 users? So that's the scalability problem. And the other thing which we have to worry about here is spectrum. So these are all wireless transmissions. when you want to transmit in a wireless, if you want to transmit a wireless signal, you just cannot start transmitting on any frequency you want. Every country has some organization that takes care of what frequency is allocated to whom. So for example, in any country, some frequencies will be set aside for, let's say, FM radio, AM radio, TV transmissions. If there's an airport, it has a radar, there will be some frequencies allocated to it. There are some frequency bands which are set aside for everybody. You don't need a special license for doing that, right? Called the GSM band, ISM band, sorry, industrial, scientific, and medical band. But they're very small. Your Wi-Fi operates on that band. Your Bluetooth operates on that band. If you have a cordless phone, it operates on that band. If you have a microwave on that in your home or your apartment, when you turn on the microwave, it actually emits some frequencies, right? That's when it's radiation. It's in that band. So everybody is sitting on that band. And you want to put 550 billion more devices on that band? Not going to work very well, right? So that's an issue. So what's your other option? I'll say, oh, I'll go buy some frequency from the government. That's what cellular network operators do, right? So you have spectrum auctions here. And I think there was a 2G, what do you call it? Scam or Ghotala or something like that, right? So there's a lot of money to be made. But that's a different thing, right? But the point I'm trying to make is, spectrum is not cheap. If you have to support 50 billion devices effectively, you may need a lot of spectrum. Or very, very smart technology. Since we don't have unlimited spectrum, we have to think in terms of technology that can allow us to have large-scale access for devices. The other thing is power savings and management. Now, we were talking about different kinds of devices. These devices may not have that many limitations in terms of power, right? But the other things, you have to worry about power. If you have deployed a sensor somewhere with a battery, maybe a pencil battery or maybe a coin battery, you don't want to go every week to change that battery. You don't even want to go every month to change the battery. What you want is, I deployed it, at least it works for 5 years or 2 years, something like that, right? We're talking in terms of years. But if you don't plan your network protocols and other things properly, you will spend a lot of energy just transmitting the messages, and your device will be inoperable in just a few months, a few days maybe, right? So there's a lot of work to be done in terms of power savings. I didn't delete these two lines in the same, right? And the other thing is security. Now when we are talking about all these applications, right? We say, okay, you have medical applications, you have this application, you're controlling your power grid. What happens if somebody gets in, right, and hacks into your system? There's potential for large-scale damage. There's potential for human loss of life, and you don't want that, right? I'm going to give you an example. So we're talking about medical devices, right? So many people with heart conditions, they have a pacemaker, right, that triggers the heart to beat. And modern pacemakers, what they have is, they have a radio. So the doctor can connect to the pacemaker inside the person's body in order to get data, to reprogram it, for example. You know, depending upon your health conditions, the signals that the pacemaker is giving to your heart may have to be changed with time. So you don't want to operate again and take out the pacemaker and program it. So having a wireless interface is good. But if it is not secure, I can go in and change the thing and you die, right? So now we have Donald Trump as the president. Before him was Barack Obama. Before him was George Bush Jr., right? And George Bush's, I think, Secretary of State or Secretary of Defense was a guy called Dick Cheney. In my opinion, just as evil as, well, more evil. These days, compared to Donald Trump, George W. Bush looks so nice, right? Anyway, so Dick Cheney, he had a pacemaker in his heart. As soon as he heard it, he got his doctors to turn it off, because he was so scared that somebody will hack into his pacemaker and turn it off or do something, right? So these security concerns are very, very real. I'll talk more about it tomorrow and give you some more examples of what has happened and so on. But security is definitely a concern. Any questions so far? Yeah.
Need to wireless connector or it may be wired?
It could be wired. So just because it's IoT, Internet of Things, doesn't mean it has to be wireless. It could be wired. It's just a machine generating data or getting the data. As an example, in the power grid, so let's say you have a smart grid, a power grid which is generating data, giving you electricity in your home. There, in most cases, all their devices are wired. Because, you know, their things don't move around like the truck. The truck is moving around, you have no way, it has to be wireless. But if you're a power grid, you have a generator, you have those wires, you don't need wireless. There is a wire directly there. Right? So in those cases, it could be, it doesn't have to be wireless all the time. Anything else?
Sir, can we use a native radio concept in IoT?
Yes, you can. And then I'll talk a little bit about that towards the end of the day today.
Sir,
Yeah.
cloud computing will be always be a supporting backup in case of IoT with any scenario?
Not in every scenario. So for example, when things are critical, so let's say if I'm a power grid company again, I am very, very concerned about things leaking outside. I will not send my data outside. If I go to a cloud provider like Amazon or Microsoft or whoever it is, they will give me all kinds of guarantees. But I can never trust it. So if it is a critical application, I will not send my data all the way to the cloud, to the public cloud. I may have servers of my own in-house. I will not send it to the cloud. The architecture would look something similar like we had here. Sorry, this one. We have devices, a network, and a server. Just that this is private. You cannot get, hopefully you cannot get in there. Yeah.
In practical scenario, is the GSM protocol only used for international?
No. Many other protocols. And the second half is all about these protocols. GSM is one option, but not the only thing. And in fact, GSM, you know, since it operates on the licensed frequency, you have to pay money for it. So you know, if I deploy, so I don't have any money, so I wouldn't go GSM. But you know, some other things may require GSM.
And two devices like Bluetooth is communicating to each other and not sending data to the internet. So it might be a case of IoT.
It could be. It could be. And the common term for that is device-to-device communication. You know, my phone may want to talk to your phone to sync up or whatever, right? In that case, it doesn't have to. But then it depends on the network topology. Am I directly connected to you, or do I still have to go through some route to get to you? But it's not necessary that all the data has to be exchanged to the cloud. You and I can exchange data too.
Like that personal area network by Zigbee, the two Zigbee are connected.
That's right. That's right. I can connect to my computer or to a printer, or you know, in many industrial applications, you just want to connect to the machine there from your tablet or laptop. So it's just two devices talking to each other.
So whether it's a case of IoT?
It's a case of IoT, sure. All right, so let's move. Did we do these things? No, we haven't done these, right? Okay, so now let's look at some of the architectures. But when I say architecture, more from the communications perspective, right? So let's look at how we want to organize our network or the communication backbone in order to support IoT. This is the most general picture that you will see in terms of how your IoT is organized. Again, you have your devices, sensors, actuators, and so on. Usually what you will see is they will connect to a gateway. They cannot directly connect to the servers on this side. Right? They will usually connect to some kind of a gateway or a base station or something, and then this gateway or the base station will connect to the network and ultimately send the data to the cloud, for example. And again, what does this gateway use? It could be anything. It could be a cellular network, it could be satellite, for example, even. It could be an Ethernet or a cable connection coming to your premise. It could be anything else. And then at the application side, you will connect to the cloud or whatever in the code, and then you'll get your data. That's the most general thing. Now we can look at the architecture in a little bit more detail. So this is the application domain, the network domain, and the device domain. And in the device domain, you have three things. You have the devices themselves, the ones that are generating or consuming the data. Right? And these are usually capable of transmitting data. And again, when we talk about things towards the end of the day today, most of the time we are talking, if it is wireless, usually a few hundred meters. That's the personal or local area network kind of thing, few meters to few hundred meters. But more recently, for example, with cellular networks, 3G, 4G, and 5G now. Actually, last week I was in a conference, and 5G isn't here yet, right? So we are still in 4G. And if you have been in this networking area for the last 4 or 5 years, you'll see people talking about 5G, 5G, 5G. And last week, there was some guy there's a company called Huawei, a Chinese company, which is sort of taking over the roles played by Ericsson and other people in the past. And now they're also talking 6G. So, anyway, things move fast. Yeah. So traditionally we will talk about local area networks or private area networks. These devices would transmit only a few hundred meters or so. But increasingly, we are also talking about wide area networks. For example, with the cellular thing. And there are other competitors to cellular networks which can transmit data few kilometers or few miles and so on. So wide area networks. But these will have capability of that. And in most cases, this M2M area network, whatever area it is, local, personal, wide, usually the device will connect to an M2M gateway. And the gateway will have various kinds of capabilities. So for example, if your device cannot do many things, let's say you have a very, very simple device, very simple processor, not enough battery. One of the things we worry always about is, when I'm sending data, I have to do authentication. So what is authentication? For example, when you want to do email, right? You check your email, you have to log in and you have to use your login and password. Why? Because that tells the server that you really are a valid user. You are the user you're claiming to be. Even with IoT devices, I only want real devices to send data. You don't want me to be able to send data to your system saying, the dam has broken or electric power is going crazy somewhere else. You don't want people to pretend to be IoT devices and send fake data. So authentication is very important. But if I want to do that, what happens? I have to do cryptography. That's computationally very, very complex. It takes a lot of power to do such things. So an IoT device, if you ask it to do cryptography operations, it will die in 3-4 days. It will not have any battery left. But I still want it to authenticate itself. So what I will do is, I will say, okay, your job of authentication is being delegated to this gateway. The gateway will authenticate on your behalf. Right? So when I came in to India 2 days back, I signed on behalf of my children. Right? They're young, they cannot sign. So that's why I authenticated on their behalf. Right? So I'm their guardian or whatever. So a gateway can do similar things, and it can do certain things on behalf of the IoT devices. And then these things are fairly small, so simple. In the network domain is essentially the communication network, which takes care of taking from the gateway all the way to the application or to the cloud or wherever your data wants to go. And the applications are they contain the middleware layer or any other kind of thing which you need in order to process the data and act on that data. That's what the application does. And this is another higher level architecture, goes in a little bit more detail. So again, we have the devices at the bottom. And I said devices connect to the gateway. Right? And there are very many variations of this. In some cases, you may not be able to connect directly to the gateway. So many small devices, for example, they may connect to an aggregation point, which is sort of a mini gateway, if you think about it that way. So fundamentally, in my mind at least, there is not much of a difference between an aggregation point and a gateway. You are still connecting to this thing. This is taking your data and forwarding it along. Right? But in terms of terms people use in the industry or in academia, you will see things like this. Now, there are specific architectures for the case of a home, for example. Right? In the case of a home, you have a gateway. And somebody said cognitive, right? So here you see cognitive gateway. So you can have that thing. But anyway, so in this case, the idea is that there's a gateway in the home, and all the devices in your home, they could be, for example, your TV, or your entertainment system, your phones, or your sensors, your temperature monitors. Everything connects to the gateway, and then the gateway takes it out. And then coming to 5G, right? One of the things that 5G says is, we will give you data rates in order of gigabits per second. You will have so much less latency and so on. Right? How does that work? That only works if, for example, so if you're familiar with wireless communications, right? So the data rate that you get depends on the signal to noise ratio. It's something called signal to noise ratio. We have a thing here, right? But we don't have chalks and okay, wait. Oh, thanks. Oh, I haven't used a chalk in a long time. But that's really good. Right, so there was this guy called Shannon, right, a very famous information theorist. And what he said is that the data rate that you get, right, it's proportional, let's say, to the bandwidth that you have, and some log of signal to noise ratio. So when you transmit, let's say you send this is an antenna, you send an electromagnetic wave. By the time it reaches the destination, the signal power will decrease. Right? And then there's all kinds of other noise in this environment. So the data rate that you get is somewhat proportional to the signal to noise ratio. So what you want is very high signal, low noise. And the problem is, if you're far away, right? If you're sitting right here, I talk, you have a large volume, you can hear me well. You go far away, you can't hear me. Right? The signal attenuates very, very quickly, sort of like this, right? Exponentially. So what happens? Our signal, if I'm far away, my signal isn't strong enough. So what 5G says is, I want to have this higher. If I want to have this high, two ways. This has to go up, right? This has to increase. I cannot increase my bandwidth because it's costly. I have to pay a lot of money to the government. So I want to increase this. Noise, I cannot always decrease. There's some environmental noise all the time. I can't do anything about it. So I want to increase the signal power. Two options. Transmit at a higher power. Shout. Instead of talking normally, I can shout from here. The equivalent would be transmitted at a higher power. Or make the distance between the two antennas smaller. And that's the approach of 5G. Instead of, right now what it is, if so my cell phone, I think I saw a cell phone tower somewhere here, around the corner here, but at least it's a few hundred meters, right? But what 5G says is, every room will have an access point. That's where it's sort of going. And it's not just every room has an access point, probably every room has 5 access points. And in the crazy world of 5G and what people talk about, every device has its own access point. And I'm not kidding, I'm not joking about it. That's what people are imagining these days about every device having its own access point. So in that sense, this is just a representation that the whole home has one access point. In many cases, a home will have multiple access points. So for example, where I live now in Singapore, they're all tall buildings there. Right? I live on the 11th floor and so on. So when you have tall buildings, you want it to be strong, so your walls are pretty thick. So if you put an access point in your living room, and in the bedroom, let's say, you don't get much Wi-Fi signal. So there itself, we have different access points in different rooms, right? And this whole thing will probably go, but it will be more general rather than having just, by the way, you should have said that this is not visible. Can you see what I wrote from the back?
Yes.
Oh, okay, right.
Yes.
If you can't see, just let me know. All right. Okay. And this is sort of what the cellular network architecture with IoT would look like. So again, you have these IoT devices. And again, another thing you will notice is the terminology changes based on who you talk to. In the cellular world, which is primarily dominated by an organization called 3GPP, Third Generation Partnership Program. They came up with 3G, they came up with 5G, now they're coming up with, they came up with 4G, now they're coming up with 5G. These are not IoT devices anymore. These are called MTC devices, machine type communication devices. They are IoT devices, okay? It's just a fancy way of calling them. And they may directly connect it to a cellular base station. Or they may, for example, if you're too far away from the base station, what do? Your signal level is pretty low. So you connect to a smaller base station, sort of, called a relay node. So you connect to the relay, oops, what did I do? You connect to the relay node, and then the relay node will forward your data to the actual base station. Right? And then there are different kinds of base stations, heterogeneous base stations. So right now what you have outside is what is called a macro base station. Macro means covers a large range. Right? You also have micro base stations, femto base stations, and so on. So when we are talking about 5G and so on, there will be base station for this room. And even, it doesn't have to be 5G. Even if you look at what it is now, well, I came yesterday when it was already dark, but what I can make out is this is fairly flat, right? And there are a lot of open spaces in the BHU campus and so on. Right? So what I'm trying to get to is, there are a lot of people here, but the density is much, much lower than if you go to the center of the city, right? Their population density is much higher. So you have to, your base station has to support a lot more people. So if I have to support a lot more people, what happens is, your cell sizes become smaller. So you will see base stations much more close by. Right? So not all base stations are the same. Some may be macro, micro, and so on. And these HE node B, or heterogeneous base stations, represent that. What am I doing on time? 16. So that's about 1 hour, right? So we can go a little bit more probably. Yeah. Oh, okay, so these are more like control signals that the base stations have to exchange. Okay? So in the old days, what would happen is, so this is 2G days, right? In the 2G days, what we'll have is, we would have base stations. Maybe I don't want to use blue, maybe white is better. Yeah. So let's say these are 2 base stations, right? Or let's make a few more base stations, so 3 base stations. What would happen is, a number of base stations would be controlled by something called a base station controller. And as an example, let's say you're on a bus or a car or something, and you're driving, and let's say you're not driving and talking. So let's make you the passenger, right? You're sitting in the car or the bus, and you're talking on the phone. So initially you are in the range of this base station. You're here. Alright. Let's move it up so my figure isn't so bad. Right? So we are here initially, right? But we are in a car, and so we are moving. And so we go here. When I'm in this position, let's say, or near the edge, what is happening? The signal I'm getting from this base station gets weaker and weaker and weaker, right? And at this point, the signal from this base station is stronger than this. And if I keep going, at some point I will not even be able to hear this. So at this point, what has to happen? I have to switch my connection over to the other base station. This is what is called a handover. Handover. Is it too small? Can you read what I wrote, what the letters I wrote?
Yes, sir.
Okay, thanks. Handover or handoff. Right? So I have to go from this base station to this base station. So now, there has to be some coordination between these two. Right? Somebody has to tell this guy that, you know, this user is no longer with you. And somebody has to tell this guy, a new user is coming, please allocate some channels to this user. This is the job of the base station controller. Right? So when the user is moving, what is really happening is, so where is my phone? I kept it there, right? So let's say this is my phone, right? Let's have a real phone. So this is my phone. I'm not doing anything on this right now. But what it is doing is, it's measuring signal. So all the cell phone towers around, they periodically send out what's called a beacon signal, telling I am a base station. This is my ID, and so on, right? So it's getting all of those. And I'm on a Vodafone network right now, so it's getting messages from all the Vodafone base stations around. What it does is, for every beacon it gets, it measures the signal strength. Saying base station 1, I got this much, base station 2, I got this much. And twice a minute, roughly, every 30 seconds or so, it sends that message to the base station. So right now I'm here, right? No, that's all right, that's all right, thank you. So here, right, let's say I was here, I'm measuring all this. So I get the signal from here, I get the signal from here, and maybe I get the signal from here. I get all those three measurements. I send it here. This guy sends it here. This guy decides what's happening. Is his signal strength increasing, decreasing? Is this guy with whom currently I'm associated with, is it still my best option? Or should I be transferring over to this guy? Job of this. And when it decides that this base station is better for me, it starts the handover process. This is 2G, 3G. In 4G, we don't necessarily have to go through this controller anymore. They can talk amongst themselves. And that's what that represents. There is signaling just between the base stations themselves. Questions? Hari? Mike? All right, thanks. No? All right. So now we can. Oh, it's in my hand. Right. I think logically this might be a good time to take a break, because then when we come back we can talk about protocols, stack, and so on. So I think there's a good logical separation between these two topics. How long do you want to break for, Hari? 10 minutes?
Yeah, we have 10 minutes left. Once again, we have to be here.
Okay, so it's 2:23 now, so we'll see you at 2:33. You're using a network. Even if it's say one hot line, even if I'm connected to you, I'm using a network based to get to you. IoT doesn't necessarily mean it has to go through US or the way it can be. We're using a network. Depends on what your Bluetooth device is getting the data from. You're using it to send your own messages, so human is generating it. And maybe it's not fair to call it. But if you're connected a sensor to it, and the sensor is automatically giving you the consignment. So by definition, that's not the IoT.
सर वो हम लोग को लेना था वो सप्लाई जो हमने बोला था
It's not machines which are coming. So who is generating that? Human or machine? You are typing it. It's not.
वैसे 10 बॉक्स लिए थे और उसके साथ 20 डॉक्यूमेंट
Network, we are using the network, but
Something like
50 उसमें 4 थे मतलब इफेक्टिवली 2000 स्टेप हो गए हाँ 10 बैग दिया था उसके साथ 20 डॉक्यूमेंट दिया और ये हमने दिया था सिस्को बायोनेट ट्वीट करके है आपका वहाँ पे नोएडा में तो वो हॉस्पिटल में उन्होंने डिस्ट्रीब्यूट किया था फिर से हम लोग को चाहिए ही हम लोग चले गया बोलने को ठीक 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 तो मैं आपको अलग से मेल वो अलग से मुझे मैं मेल आईडी अपना दे देते हैं तो अलग से हम लोग बात कर लेते हैं उसमें उसी मेल बॉक्स में डाल आपकी मेल अच्छा तो आप दिल्ली आ रहे हैं मुझे एक्चुअली आप दिल्ली पहुँचे तो मैं बात करता हूँ आपसे मैं बनारस में चाहिए हम लोगों को सप्लाई तो आप दिल्ली आ जाइए तो मैं आपसे बात करता हूँ ठीक है मंडे को ना
अल्टरनेटिव बोलिए क्या कितनी हर मतलब कुछ नहीं समझ में